and a span. They're not always written as that on a transmitter, and I think on these first temperature transmitters, it's represented by a 0 with 2 arrows pointing into it. That's the 0. And if we have something that the arrows are pointing away from each other, that's the span. So if we would connect up 100 ohms over here, remember it's plus or minus 0.14 ohms, we would put that sensor input over here. We would connect up our loop over here, read our current coming out, and if we don't have 4 milliamps coming out of this transmitter, if we don't have 4 milliamps going through this current loop, we would adjust that screw right there until your current meter reads 4 milliamps. Now over on your proto board, you have another set of resistors that equals the resistance that 150 degrees centigrade would be. And however many resistors it takes to create that, that's what it creates. Now once you set your 0 or your lower end of this transmitter's range, you have to move these wires that are connecting the transmitter up to your simulated temperature over here. You have to physically move them over to this. Everything else stays the same over there. We're still measuring current through this loop over here. But you physically have to disconnect the wires that are going here, and you would physically move them over to this set of resistors. And along with that, you should see your current go up over there. It should go up to 20 milliamps, and in a calibrated device, it would be at 20 milliamps. But if it doesn't read from this input over here 20 milliamps, you have to get on your span and adjust that until your current meter reads 20 milliamps. Anytime you have to move one of these adjustments, 0 or span, you have to go back to the other range to see if it actually shifted any. If we had to adjust our span because this set of resistance didn't equal 20 milliamps, so we had to adjust the span to make that happen, we would then have to move our wires physically back over to the other set of resistors to check our 0. If we have to adjust the 0 again because we're not reading 4 milliamps over there, then we have to physically move those wires back over. And this is a continuous process, back and forth, until we don't have to change either one of these adjustments. And no matter which set of resistors that we put our wires on, we read these two currents coming out of the transmitter. Once you do that, you have calibrated that transmitter so that anywhere in this range of temperatures, 0 to 150 degrees C, if we simulated 75 degrees C over here, we would read the same percentage of that over here. 75 happens to be 50% or half of this, so we would actually read whatever represents 50% of this scale. We will be practicing this. There's a lot to it. It's a very simple thing. When I stand up here and I draw this over here and I can make everything very laid out and very organized, when you start creating this on the workbench, you're going to have a set of power supply leads coming out of the power supply. You're going to have a set of meter leads coming out over here. You're going to have at least 3 clip leads coming off of that transmitter, excuse me, going over to these resistors over here. And if you don't keep it neat and orderly, you're going to get confused on what's what. Be able to sit down and draw this wiring diagram out on your own. It's going to help you off a lot better. This is an RTD temperature transmitter calibration.